expressions and rational exponents. And so on this first page, what we're doing is we're converting from a rational exponent into a radical expression. So I'm just going to work through these ones quickly. So actually a quick note before we start. If we have x to the a over the b is a fractional or a rational exponent, we can rewrite this as a root where b is the root, x is the base or the radicand, and a is the exponent. So on top a is our exponent, and b, that's our root. So we're going to apply that when we rewrite these expressions. So 10x to the 4/5, that means that under the radical, I have 10x. I'm taking the 5th root, and I'm raising it to the 4th. But you've got to be careful. If I just put a 4 here, it looks like I'm just raising the x to the 4th when I'm actually raising the entire expression to the 4th power. So you actually need to have parentheses and put the 4 on the outside. The parentheses are important. For this one, I have the 3rd root of 5x. This is just raised to the 1st power, so I actually don't need to include that in my answer. I'll go ahead and highlight these. That's the solution. All right, 2v to the 1/4. That means that we have the 4th root of 2v. It's raised to the 1st power, so once again, I do not need to include that exponent. 7a to the 1/2, that's just the square root of 7a. I don't need to put the 2 there because if there is no number, if there's no index, it's assumed that it's a 2. X to the 1/2 is just the square root of x. 5x to the negative 3/2. What that means is that my root is 2, so I'm taking the square root of 5x, but I'm raising this to the negative 3rd power. Now, we know that negative exponents are not okay, so what this really means is I have 1 over the square root of 5x to the positive 3rd power. But as long as you got this, you're good. But this would be the final simplified answer for that. And if I have 10x to the 5/6, that means that I'm taking the 6th root of 10x, and it's all being raised to the 5th. And 6n to the 5/2, that means that I'm taking the square root of 6n raised to the 5th power. All right, in the next section, we are doing the opposite. We're turning these roots into rational exponents. So this first one, I have 5x. The exponent would be a 1, and I'm taking the 3rd root, so this would be to the 1/3. However, this just makes it seem like x is being raised when actually the entire thing is being raised. So once again, you need to include the parentheses there. Here I have 7m is being raised to the 3/2 power. Once again, I want to raise the entire expression, so I'm going to use parentheses. Here I have 3a being raised to the 1/3 power. Here I have 7p being raised to the 5/2 power. This is 5n to the 1/4 power. This is x to the 1/2. Parentheses are unnecessary because I just have an x. Here I have 4r being raised to the 1/3 power. And here I have 10n squared. Notice that the n squared is just, the squared is just attached to the n, and this whole thing is being raised to the 1/6 power. All right, so we're moving on to the next page where we are working with rules of exponents. So we're just going to review the rules and then work through some examples. So the product rule means that we are going to multiply. When we are multiplying exponents together, what we actually do with the exponents is we add them. Because if we had, for example, x squared times x cubed, what that means is I have x times x, that's x squared, times x times x times x, that's x cubed. Well, altogether, I have x to the 5th. So what we do is we add these exponents together when we are multiplying. The power rule is when I'm raising a power to a power. So if I have x to the a raised to the b, I'm actually going to multiply these together, x to the a times b. Looking at the quotient rule, if I have x to the a divided by x to the b, what I do is I do x to the a minus b. I subtract these exponents, top minus bottom. And the logic is similar as when we did the product rule. For example, if I have x to the fourth over x squared, I have x times x times x times x divided by x times x. Well, whoops. Well, let me scroll. Oh my goodness. Let's try this again. I have these x's will cancel and I'm just left with x squared. 4 minus 2 is x squared. So we subtract the exponents. And finally, the negative exponent rule. This is probably, why does it keep doing that? There we go. The most tricky rule to remember, but I can't have a negative exponent. So if it's negative, you move it to the bottom, you change the exponent to a positive, and you leave whatever's on top, or if there's nothing, you just put a 1. All right, so we're going to work through some examples. Anything with a star, you don't have to do, because you will not be assessed on that. So none of these need to be done. So I'm going to start with number 4. So if I'm doing negative 7 n to the negative 4 times 5n to the negative 2, the first thing I'm going to do is with my coefficients, I'm going to multiply those together. So I have negative 7 times 5, and that gives me a negative 35. Now using the the product rule, I'm going to add my exponents together. So I have a negative 4 plus negative 2. And so I will end up with n to the negative 6. Now, I cannot have a negative exponent in my final answer. So what I do is I move this to the bottom, whereas anything with a positive exponent, this is a negative number, but it doesn't have a negative exponent, so this will stay on top. So my final answer will be negative 35 over n to the 6th. All right, this next one, I've got a couple of things going on. I've got 5v to the 4th, all raised to the 2nd, times 2v cubed times v. So the first thing that I want to do is deal with my exponent here, and I'm going to distribute that in. When I do 5 squared, that's 5 times 5. It's not 5 times 2. So 5 squared is 25. V to the 4th raised to the 2nd, I'm going to multiply these, and I get v to the 8th. And then I'm going to multiply by 2v cubed times v, and this is v to the 1. So next I'm going to multiply my coefficients together, 25 times 2. That gives me 50. And then with my exponents, I'm going to add these together using the product rule. 8 plus 3 plus 1 gives me v to the 12th. And that's my final answer. All right, looking at number 8, I'm using the quotient rule, which means I'm going to subtract exponents. So I have 6 minus 5, 7 minus 4, and 2 minus 2. So for r, 6 minus 5 gives me r to the 1, or just r. S is 7 minus 4, which is 3. And t squared minus t squared, that gives me t to the 0, which is equals 1. So these cancel each other out, and this is my final answer, rs cubed. Next, I am going to be using the quotient rule, but not yet. First, I need to simplify the top and the bottom. So on top, I'm using the power rule, and I'm going to distribute this. So I have negative 3 squared, which is negative 3 times negative 3, which is a positive 9. X to the 6 raised to the 2nd power gives me x to the 12th, because I multiply those. Oops. On the bottom, I'm going to use the product rule. I'll multiply my coefficients. 5 times 3 is 15. And then 3 plus 3 gives me x to the 6th. Now, I'm not finished. I can simplify here. 9 and 15 are both divisible by 3, so I'm going to divide them, and then I'll subtract my exponents. So when I divide 9 by 3, I get 3. 5 divided by 3 is 5. And then 12 minus 6 gives me x to the 6th. All right, looking at number 10, I have a fraction, but I'm raising everything to the second power. That means I'm going to pass out this 2 to every single thing inside. So 4 squared is 16. X to the 4th squared, I get x to the 4 times 2, which is 8. And then I have y squared, which is y to the 2 times 2, which is 4. On the bottom, I get 6 squared, which is 36. X to the 1 times 2, which is x squared. And y to the 1 times 2, which is y squared. Now I'm going to simplify here. I can divide or find a common factor with my coefficients. 16 and 36 are both divisible by 4, and then I'll subtract my exponents. So when I divide 16 by 4, I get a 4 on top, and then 36 divided by 4 is 9. 8 minus 2 gives me x to the 6th, and 4 minus 2 gives me y squared. So this will be my final answer here. All right, the next one, I am going to, once again, simplify the top, and then I will use quotient rule to simplify the entire thing. So first I'm going to multiply 7 times 3, and I get 21. And then I'm going to add these exponents together. I have negative 8 plus negative 2, which is going to give me a negative 10. On the bottom, I still have 6k squared. To simplify, I'm going to find a common factor between my coefficients, and I'm going to subtract my exponents. So 21 and 6 can both be divided by 3. When I divide 21 by 3, I get 7. 6 divided by 3 is 2. And then negative 10 minus 2 gives me a negative 12. Well, I can't have a negative exponent in my final answer, so this is going to drop down to the bottom, leaving me with 7 over 2k to the 12th. On number 12, there's nothing I can really do on top or bottom, so I'm just going to go ahead and simplify first, finding a common factor with my coefficients. They're both divisible by 9, and then I'll subtract my exponents. So negative 9 divided by 9 is negative 1, and 27 divided by 9 is 3. Then I do n to the 8 minus 10, which gives me n to the negative 2. Since I can't have a negative exponent, in my final answer, I'm going to drop that down to the bottom, and I'll get my final answer of negative 1 over 3n squared. All right, number 13. I want to simplify top and bottom if I can. The top cannot be simplified, but the bottom, I can distribute this negative 4. So I get a to the 12th, b to the negative 3, over a to the negative 4, b to the negative 4. Now I'm going to use quotient rule and subtract to simplify this. So I get a to the 12 minus negative 4. Well, 12 minus negative 4 is the same thing as 12 plus 4. So I'm going to get a to the 16th. And then b, I have negative 3 minus negative 4.